Assalamu alaikum. Hello viewers. How are you? I think all of are fine. I am Mohammad Humayun Kabir, Assistant Professor, Engineering University Girls School and College, Kuwait Campus, Dhaka. Today I am going to discuss a very important topic, which is about ionization potential. Actually, I am going to discuss the ionization potential of beryllium, boron, nitrogen, and oxygen. We know the energy which is required to produce a unit positive ion by a positive ion by removing 1 mole of electron from that element in gaseous state. For example, if we want to this ionization potential. For example, we here see that nitrogen release, sodium releases electron, sodium ion in gaseous state. That means the energy which is required to get a sodium ion from sodium in gaseous state is known as ionization potential of sodium. Here, the amount of energy is known as the ionization potential. Now, we know in periodic table, if we move from left to right, the ionization potential will increase. This is the normal range of the element in periodic table. But in some cases, we see there are some exceptions. There are some exceptions. For example, if we consider beryllium and boron, nitrogen and oxygen. In periodic table, we know that after beryllium, it is boron. So boron should have higher ionization potential than beryllium. But actually, we see that the ionization potential of beryllium is higher than that of boron. Now, question is why? Again, for nitrogen or oxygen, this is another pair. Where oxygen is after nitrogen in periodic table. So nitrogen should have less ionization potential than oxygen, because if we move from left to right, the ionization potential will increase. But we see here oxygen has less ionization potential than nitrogen, though it should be higher than nitrogen. Similarly, the boron has less ionization potential than beryllium, though it should have higher ionization potential than beryllium. Okay. Now, question is why? Okay, we see at first we should know the electronic configuration of all these elements. Okay, these are the electronic configurations of these elements. First of all, I am going to discuss beryllium and boron. From the electronic configuration, we see that boron has 5 electrons. On the other hand, beryllium has 4 electrons. That means beryllium is before boron, so beryllium should have less ionization potential. But actually, beryllium has higher ionization potential. This is because we know if any element has full field electronic configuration or half field electronic configuration, that which will have the more stable electronic configuration. In case of beryllium and boron, we see that beryllium has 2 electrons in its outermost shell. That means in 2s orbital, it has 2 electrons. So this is the field electronic configuration of beryllium, because we know s orbital can contain maximum 2 electrons. So in this 2s orbital, there are 2 electrons. So it is full filled electronic configuration. So it will be very difficult to release one electron from the full filled electronic configuration. On the other hand, we see that boron has 5 electrons and the last electron is after fulfilling the 2s orbital. That is 2p is not full filled or half filled. We know p orbital can contain maximum 6 electrons. If there are 3 electrons in p orbitals, then it is half filled. But only we see that there is only one electron in p orbital, and it is after the fulfilled electronic configuration of 2s orbital. So it is very easy to release this electron because it is loosely bounded with the nucleus. It is loosely bounded with the nucleus. On the other hand, it is strongly bounded with the nucleus. That's why it is very difficult to release one electron from this 2s orbital, but it is very easy to release one electron from 2p orbital. That's why beryllium has higher ionization potential than that of boron. Again, in case of nitrogen and oxygen, we see nitrogen has 3 electrons in its outermost energy shell. That means in its outermost energy shell, there are 3 electrons. That means 2p3. It is half filled. On the other hand, in case of oxygen, we see that in the outermost energy shell, there are 4 electrons. That means p orbital contains 4 electrons. It is not full filled or it is not half filled. It is partially filled. We can say it is partially filled. So since this is full half filled electronic configuration of nitrogen, so it is difficult to release one electron from this electronic configuration. That means from this nitrogen atom. That's why higher energy is required. So there, for this reason, its ionization potential is high. On the other hand, here is 4 electron. That means after fulfilling half-filled electronic configuration, there is 1 electron. 3 are half-filled and 1 is excess. So this excess electron can be released very easily because it is loosely bounded. It is not strongly bounded with the nucleus. That's why oxygen has less ionization potential than sodium. That means we have seen that in case of beryllium and boron, nitrogen and oxygen, the exception is depend on the electronic configuration of the elements. And if the half fulfilled or half filled, it is very difficult to release electron from the orbitals. But if it is partially filled, then it is easy to release electrons because these electrons will be bounded loosely and it is easy to release this electron. On the other hand, on half filled and full filled, then they will be in strong electronic configuration. That means they will be stable electronic configuration and they are strongly bounded with nucleus. So it is very difficult to release these electrons. That's why they will have higher ionization potential. Okay, these are the actual reasons. These are the exceptions. And in periodic table, we will see there are a lot of exceptions, many exceptions in ionization potential. And all the exceptions usually maximum exception depends on the electronic configuration of the elements. So I think from these 2 examples, you are very much clear why we get the exception ionization potential in the periodic table. And I am very much hopeful from this explanation, you will be able to answer all the questions or will be able to know the reason of the exception of ionization potential of the elements in periodic table. With this, I am going to finish here. And from next class, I will try to give you more information about more important topic. And to get the important information, please subscribe the channel, and so that you will get the more important information. Thank you, everybody.